All right, so we're going to do notes. We've got 3 topics that we're going to be doing in this part of the unit. I call it Unit 1B. Balancing chemical equations, then stoichiometry, and then types of reactions. So these are your notes for balancing equations. Now, we first start off with the law of conservation of atoms. Now, you could also call this the law of conservation of matter or the law of conservation of mass. They all basically mean the same thing. The law of conservation of atoms says there must be, actually I'll pause this and then you can write it down. So the law of conservation of atoms says there must be the same number of each type of atom before the reaction as after the reaction. In chemistry, atoms are never created or destroyed. If you start off with 12 carbon atoms at the beginning of a reaction, you're going to end with 12 carbons at the end of the reaction. If you have 12 oxygen at the beginning of the reaction, you're going to end with 12 oxygen atoms in the end. Really what we're following here when we're looking at chemistry is we're looking at how the atoms are shuffling. They may start off with one partner when they're reactants. They shuffle and find a new partner and become a different product. But you're always going to have the same types of atoms present in the start as you do in the end. Again, they just may be switching partners, or maybe they're all by themselves now. So that's the law of conservation of atoms. They're never going to be created or destroyed. Now, sometimes you may do an experiment, and you may do the experiment and you're starting off with 34 grams of reactants, and when you end, you may end up with 32 grams of your product. That doesn't mean that atoms have been created or destroyed, in this case destroyed. What it means is you've lost some somewhere along the way. During the class period, I asked the question, what are some ways that atoms could get lost when you're doing a chemical reaction? And we came up with things like, well, some of them could get spilled on the table. As you're transferring from one vessel to another one, you weighed things out, you're pouring things together, and you've lost some on the table. That, of course, is going to mean that your product or the end result is going to be lighter than it was at the start. Another thing is if you're using liquids. When you pour a liquid from one container into another one, there's always some of that liquid that remains behind. It's going to be stuck and it's not going to be involved in the reaction. When you're looking at the weight of your product, you need to figure in, okay, some of it was left inside a beaker. The last thing is and this is one of the most common things, if you have a gas that's produced during the chemical reaction, that gas is usually going to go out into the room, and it's not going to be available to weigh it with your product. So atoms are never created or destroyed, but when we're doing chemistry, we kind of have to think about ways that we may have lost some of them along the way. They're still present, they're still around, it's just that we can't actually measure them. All right, the next definition is, and I'll pause this to write it down. Now, coefficients is kind of a nice term because you're going to use the coefficient in the same way that you would your math class. They're the numbers that go in front of each substance to indicate the number of atoms or molecules that are reacting, or if it's on the product side, the number of atoms or molecules that are being produced. Coefficients will tell you how many of each type of element or molecule you have in the reaction, and that's going to be when it's balanced. Let's take a look at an example of a reaction. The first thing I want you to do is to label the different parts of the reaction. Everything in front to the left of the arrow, these are going to be called reactants. The arrow is yields, and then anything after the arrow are products. And I think I put I before E except after C. Beep. I got that order wrong there. So reactants are on the left side of the arrow. The arrow means yields, and the products are going to be on the right side of the arrow. So as I'm reading this, I would say aluminum plus sulfur yields aluminum sulfide. Those would be the products. So what we're going to be doing is we do our balancing equations using something called the tally method. And the tally method goes like this. The first step you're going to do is you're going to write down the elements. And you can do that under the yield sign. So we've got aluminum and we have sulfur. Once I've got all the elements being used in this chemical equation, I'm ready to count them. On the reactant side, I've got 1 aluminum. On the reactant side, I've got 1 sulfur. Now I'm going to count the elements that are on the product side. On the product side, I've got 2 aluminum because it's Al2, so I've got 2 aluminum atoms. And for sulfur, I've got 3 of them. Al2, 2 aluminum atoms. S3 means I've got 3 sulfur atoms. Now, the next thing I'm going to do is I'm going to start at the top, and I look at the number of aluminum and the number on the product side and the reactant side. Well, I've got 2 on the product side and only 1 on the reactant side, so I need to get those to balance. In order to have 2 on the reactant side, if I put a 2 here, that means I've got 2 atoms of aluminum, and now I'm going to update my total. So I've got 2 on the reactant side for aluminum, and I've got 2 on the product side for aluminum, and that's balanced. Now I'm going to drop down to sulfur. I've got 3 on the product side, but only 1 on the reactant side. So in order to get 3, I'm going to put a 3 in front of it, a coefficient of 3, update my total, and now I'm balanced. When your numbers are the same for every element, we say this is balanced. So what this is telling me, I'm going to use 2 atoms of aluminum plus 3 atoms of sulfur, and that's going to yield 1 Al2S3, so 1 molecule of Al2S3. Let's try the next one. Again, I'm going to do the tally method, so I'm going to write down the elements. I've got lithium, and I have oxygen. I'm going to do my counts. On the reactant side, I've got 1 lithium, 2 oxygen. On the product side, I've got 2 lithium and 1 oxygen. So I'm going to start with lithium. I've got 2 on the product side, so I need to make sure I've got 2 on the reactant side. By putting a coefficient of 2 in front of the lithium, I now have 2 lithium. Now I'm going to drop down to my oxygen. I've got 2 on the reactant side and only 1 on the product side. The only way I'm going to get 2 oxygen is by putting a 2 in front of the lithium oxide. Now I'm going to update my totals for both of them. I now have 2 oxygen. My total for lithium has changed though. 2 times 2 is going to be 4. So I'm no longer balanced for the lithium. I'm going to come back to the reactant side, and in order for me to have 4 lithium, I got to update this to 4. Update my total, and now I'm balanced. I have 4 here, 4 on this side, 2 on the reactant side, 2 on the product side, and I'm balanced. So the final balanced equation would be I need 4 lithium atoms plus 1 molecule of oxygen, O2, and that's going to yield 2 lithium oxide molecules. Now the last one. Now this one looks kind of scary when you first see it because there's so many different elements here. But here's a trick. Whenever I've got something in parentheses, I'm going to look to see, do I have it on the other side too? I do. For the PO4, I've got it on the reactant side and I've got it on the product side. What this means is I can use a trick. And that trick is to keep that all together. Don't separate out these, they're called polyatomic ions. I'm not going to separate them out. So when I list my elements, I'm going to have iron. Now I'm going to list SO4 in 1 unit, because I've got units of SO4 on the reactant side and units of SO4 on the product side. Then I have sodium, Na, and then the PO4. And again, I'm going to just list that together. And it's going to make it much, much more simple to count these and to get everything balanced. So now I'm going to do my count. On the reactant side, I have 2 iron. I've got 3 sulfate. Because of the 3 right here means I've got 3 of those units. For the sodium, Na, I've got 3. And for the PO4, I've got 1. On the product side, I'm starting off with 1 iron. Whoops, let me change that so it looks more like a 1. For sulfate, I've got 1, which is SO4. Sodium, Na, I've got 2. And then for the PO4, I've got 1. So now I'm ready to start balancing. I've got 2 iron atoms, Fe, on the reactant side. In order to get 2 on the product side, I'm going to use a 2 in front of it. Now I'm going to update my totals. That gives me 2 iron. And now I'm going to update my total for PO4, and that gives me 2 of those. I'm balanced for iron, so I'm going to move on to the SO4. So I've got 3 on the reactant side and only 1 on the product side. So I'm going to change this to a 3 and update my totals. Now I've got 3 times 2 for the sodium. That's going to give me 6. And I have 3 SO4. I'm balanced for iron, I'm balanced for SO4. For the sodium, I'm not balanced anymore. So I'm going to go back over to the reactant side, and I have to have 6. If I put a 2 in front here, now I'm going to have 3 times 2. I'm going to update my total. I have 6. The PO4, I'm now going to have 2 of those, and that's going to give me 2. When I have 3 in front of this, that means I've got 3 Na2 SO4. Here's another one. That 3 means I've got 3 molecules. I've got 1, 2, 3 of these to get balanced. So if we're looking at the sodium, this one has 2, the next one in the middle has 2, and the third one on the bottom has 2, so that's going to give me a total of 6 individual sodium atoms. You can see that I've got a unit of SO4 right here, another unit of SO4 here, and another unit of SO4 here, giving me 3 total units of SO4. The same thing is true over on the other side. It's on the reactant side, it's telling me I have 2 of the Na3PO4. I've got 2 units of that. So when I'm totaling up my sodium, I've got 3 here. I've got 3 here, and that gives me a total of 6. I've got 1 PO4 and another PO4, and that gives me a total of 2. So when you're adding these up, when you have a coefficient in front of the element or the compound, it's just telling you how many molecules of that element or compound you've got. So the trick is to, if you can see it on both sides of the equation, keep them together. If you don't see it on both sides of the equation, these polyatomic ions will need to be split apart. That's all for now, and then we went ahead and we did the PhET simulation. That is, the link for it is in Classroom.